All right, going. All right. Is that too loud? Is that too loud? I feel like I'm screaming. Oh, sounds weird. Folks, sorry about that. We're in good shape right now. Oh, it's not even on right now. Let me back up a bit here. So I hope that gives you a little bit of time to kind of go through this investigation. Now, this next unit is called analytic geometry. Yeah? It's kind of strange because it involves points, it involves lines. Again, it's going to involve slopes and equations of lines. And when we plot lines, or perhaps maybe we're talking, instead of lines that go on forever and ever and ever, now we're kind of looking at just a segment of that line, like a piece of that line. So when we're talking about line segments, there's much to know about them, like the middle point, yeah, midpoint, that's today, perhaps even how long the line is. And if you have multiple lines, they can all create some sort of geometric figure, like a triangle, like different types of triangles, like a right triangle, equilateral triangle, isosceles triangle, scalene triangle, or even a right isosceles triangle. Yeah? And also, there's a lot to tell from that, from plotting points and creating different line segments. So this is the last unit that's going to be focused around lines. And it's like, we're going to be graphing lines, plotting points, and then really analyzing what we have. Yeah? It's pretty much what the whole unit is all about. Now, the first couple of lessons, midpoint, length of a line, equation of a circle, things like that, that's to kind of get the tools in your hands. After that lesson, we look at verifying geometric figures, which is like, that's the real stuff. That's the real analytic geometry. So, in this first part here, the midpoint, does anyone have an idea? Did anyone have a chance to complete this thing? Give it a shot? Yeah? Okay. Before we even get into midpoint, I'm sure if we had a piece of a line, yeah, where would you think the midpoint would be? Yeah, you're in the middle of that piece of line, yeah. So we could say it's the point that divides a line segment into two equal parts. That's where the middle would be. So in this investigation, we had to plot the points A, which was 2, 5. So we start at the origin, 2, 5. Lovely, that's point A. And then point B is 10, 5. Point B over here, 10, 5. Draw the lines. So we plotted the 2 points. Great. Draw the line segment connecting the 2 points. Okay, so I'm going to pull out a straight line. And for you folks, that might mean a ruler. You got one. So that is line segment AB. Yeah? Notice how it's not like, not yet looking at the equation of that line, slope of that line. No, hold on, just hold on a minute. Just, here's a line segment from A to B. Okay. It says determine the point that is in the center of the line segment by any means possible, using anything. Anything. Does anyone know what coordinate is directly in the middle of this line segment? Do you have a chance? Yeah, Camille? 6, 5. Let's have a look. 6, 5, right there. Does that look, we'll call that the M of AB. So capital M meaning the midpoint of which line segment? So we put a little subscript here, like below here, of AB. So do we agree with that? How are we so certain that this is the midpoint? So we say that it is coordinate 6, 5. 6, 5. Why are we so sure? Yeah, Ryder, what do you think? What do you mean by that? Oh, if you didn't hear that, Ryder said both sides are equal. And I said, well, what do you mean by that? And he said, well, the distance from A to the midpoint looks like it's about 1, 2, 3, 4 units, right? You see how that's about 4 units? And then the distance from B to the midpoint, 1, 2, 3, 4, that's another 4 units. So because they have equal distances, we can say that, that point is right in the middle. It says calculate the length of the line segment from A to the midpoint, we got it, which is 4. From B to the midpoint, we got it, If your answer in part 3 is correct, how should these lengths compare? Well, they should be the same size, right? They should be both equal to 4. Okay? So from A to the midpoint and B to the midpoint, they have to be equal. So this is line segment, or sorry, point, 6, 5. Now let's take a moment. We have coordinate A, which is 2, 5, and coordinate B, which is 10, 5. Now, what if the line we were given wasn't as, I don't know, as pretty or like as simple to do, just to count it out with our fingers. So you can actually count this one out, and we know that that is for sure the midpoint. Now, what I want to ask, I think, is what do you notice about the relationship between the x values in coordinate A and B, and then the x value of the midpoint? Yeah, what do you notice? If you add them together and divide it by 2, okay, so essentially we have 2 plus 10, and then you divide it by 2. Is that what you're saying? And that'll give us 12 over 2, which inevitably gives us that 6. Yeah, absolutely. So I guess what you're saying is we're taking the average of the x's, right? Because we're taking 2 of them and then adding them together and dividing by 2. That's kind of like the average. And we shouldn't be shocked by that, because if you look here, it's kind of what we did. We're like, okay, there's 2, there's 10, and in the middle of 2 and 10, now because this drawing is so nice, we're able to just count. But if we weren't able to count, we'd have to take the 10 and the 2, add them together, get 12, divide it by 2, and that'll give us that middle point of 6. Now, I think for this example, we were quite lucky, because how about the y? The y portion of this. We got 5, we also got 5, and then we also got 5. Does that adding them together and dividing it by 2 still work here? Think about it. 5 plus 5, right? 5 plus 5 is 10. Divided by 2 is 5. Yes. It's all good. So, when we're dealing with the midpoint, and we have 2 points, arbitrary, they could be random points. The way we get the midpoint of anything, A, B, let's just say for example, is by coming up with this little, it's kind of, it's a formula, but it's a coordinate. A coordinate is in brackets and it's got a comma, yeah? So what we're doing is to get the x part of the midpoint, we're going to take the first x value and add it with the second x value and then divide it by 2. That's how you get the x part of the midpoint. And for the y part, it's the same idea. Take the first y value, add it together with the second y value, and divide it by 2. And that right there is the midpoint formula. And we got to remember, maybe we should even write this down, that this right here, this is a coordinate, right? It's going to be in brackets with a comma between it, always. Questions so far? Pretty good? Okay. So you determine the coordinates of the midpoint M of the line, just line segment joining A, -2, 3, and B, 6, -8. Calculate the distance from M to B. Okay, I think what we're going to have to do here is graph this as best as we can. Just give me a moment. I'm going to pull up my my graphing tool just to show you what this might look like. Drafting tool, lovely. I'm going to steal this graph, maybe paste it in. Whoa, that's a big one. Okay. Maybe just off to the side here so we can see what's going on. Let's just look right here. So we want the midpoint of this line set, A, B. So we'll start off by first calculating that using the formula. The midpoint of AB equals x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. That's the formula we're going to use here. Now, very similar to that slope formula, remember how we call the coordinates x1, y1, x2, y2? Same idea is going to happen here. Because this is coordinate A, called the first coordinate, every coordinate or ordered pair has got an x and a y. So this will be x1, y1. Coordinate B, an x and a y, we'll call it x2, y2. Similar to the slope formula, it doesn't matter which one you name, as long as you name them consistently. Yeah? If one coordinate's x1, y1, the other one's x2, y2, we're going to be in good shape. So, the midpoint of AB, so we'll do x1, negative 2 plus 6 divided by 2, and then 3 plus negative 8 divided by 2. So we'll get something like negative 2 plus 6, 4 over 2 for x, negative 5 over 2 for y, and then finally, our midpoint 4 divided by 2 is just 2, and this is going to be a little strange, but this can happen. You get 2 and negative 2.5. Okay, so let's see what this looks like on a graph. A is negative 2, positive 3. That's coordinate A. Coordinate B is positive 6, negative 8, just down here. And we're going to connect this line segment the best we can, like that. That looks pretty good, pretty straight. Okay. Now, our midpoint we set is 2, negative 2.5. Oh, and it's right on there. That is the midpoint. Right here. It says calculate the distance from M to AB. Well, I think, how would we calculate distances here? Do you have any ideas? Like this is where, we're really reaching back into our grade 9 toolkit. And from the midpoint to B, well, what if we kind of created this right triangle, yeah, from those two coordinates? What is this vertical change here? Well, it's 1, 2, 3, 4, 5.5. Yeah, 5.5 units high. Agreed? 5.5. And then this one down here would be 1, 2, 3, 4 units. So if we really wanted to calculate the length of anything, we can create a right triangle, just like that, and use the Pythagorean theorem. Agreed? Now, using that same idea, how about from A to the midpoint? Here's the midpoint here. How tall is this right triangle? Well, 1, 2, 3, 4, 5.5. Are we shocked that it's 5.5? Maybe not. Over 1, 2, 3, 4, and over 4. So both of these right triangles, they both kind of rise -5 and run 4. Yeah? Rise negative, it's weird to say rise -5. Rise -5 and run 4. And because they both have the same rise and run, they're for sure, they're actually one and the same triangle, so the distances are for sure going to be the same distance from A to the midpoint and from B to the midpoint. Cool? Yeah? Does it sit well with you? Okay. Proving properties of geometric figures. So here's a great introduction to what this unit is about. Let's say we have a rectangle. We have points A, B, C, and D. Okay. A is 6, -9. B is -1, -11. C is -5, +3. And D is 2, 5. Draw the rectangle on the grid. Okay, so I'm pulling out some sort of straight edge here. I'm try my best. Okay, good. Lovely. Okay. Looks like a rectangle, right? Okay, draw the rectangle on the grid. Got it. It says here, if the figure is a rectangle, what should be true about the coordinates of the midpoint of each diagonal? Now, when they say the word diagonal, what they're talking about is, well, the diagonals that go through this rectangle. Like that right there would be a diagonal. Kind of slices it in half like that. And then another diagonal. Try to draw these in the best you can. So if this is truly a rectangle, the diagonals, it says here, what should be true about the coordinates of the midpoint of each diagonal? Well, the coordinates of the midpoint of each diagonal should be the same. Just calculate the coordinates of each diagonal. Okay. So this first diagonal we'll do will be AC. And we're going to find the midpoint of that line segment, AC. And we're going to use the formula x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay, A and C. I'm going to go to my diagram and say, okay, x1, y1, x2, y2, just so I know. So x1 is 6 plus -5 divided by 2. Okay. We got -9 for y1 plus 3 divided by 2. So we should get something like 6 plus -5 is +1 over 2, and then -6 over 2. So in a decimal, that'd be like 0.5 and -3. So that one is right here-ish. And that looks pretty promising, doesn't it, on the graph? Okay. Okay, the next diagonal we're going to do is BD. And the same idea, we should always be starting with this formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. So BD, I'm going to go to my diagram here, x1, y1, x2 and y2. So we can say negative 1 plus 2, and negative 11 plus 5. So we'll get 1 over 2, comma, negative 6 over 2, which is 0.5, negative 3. Which, if you look, that's the same point, which is great. That's what we're looking for. That's kind of like a good intro of what we're doing here. We're going to do some math, solve for this, solve for that, and then kind of analyze it. We're like, oh yeah, this is good, this is good. Now sometimes, depending on the graph you have, like this is a perfect computer-generated graph. The squares are perfect squares. Now sometimes if perhaps photocopier made it a little wonky, or if someone maybe pulled the image and stretched it in a weird way, it could really mess things up for your graph. So a lot of the times, I mean, the graph is great. The graph is a great start. It's always good to have a visual for sure. But really the math is the one that speaks the volumes about what's really going on here. It really confirms everything for us. Because if you look here, like negative 0.5 and, 0.5, negative 3, on my graph personally, it doesn't, like it's reasonable to say that they intersect there, but it's a little off, you might say. But the math here really makes me sleep at night. It's like, okay, yeah, this is all good. Questions so far? Midpoint formula? So far so good? Love it. Okay, weird question. Very, very weird. Because to get the midpoint, it's not the wildest thing. You're like, okay, give me the recipe, boom, 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 boom. You got the formula, you know how it works, it's great. This is a weird one. Because they say if the midpoint of line segment EF is negative 3, positive 4, and one end point, so the line segment has two ends, one of those endpoints is 1, 2. They want us to solve for the other endpoint. Think about it, it's a little weird, a little bit of a weird request. Now, I don't know about you, but I'm a very visual person. I need to see what this is going to look like. So let me paste one of these on here so we can see this. And you don't really have to draw anything here. I just want to see it for my benefit and also for your benefit. So we got a line segment. Well, we know two things. We know the midpoint of the line segment is negative 3, positive 4. 1, 2, 3, 4. That right there is the midpoint of line segment EF. And what we know is that the other end point is E 1, 2. So 1, 2. This is E. You don't have to write the coordinates, I'm just writing them. Now, just by looking at this graph, where do you think roughly would the other end point be on line segment EF? Like, where's that point F going to be? Is it going to be over here? Getting some shakes. Is it going to be over here-ish? Somewhere around here? Yeah? Okay. Yeah, it will be somewhere around this area because this is the end. This E is the end point. It doesn't go past this. Yeah, and that's the middle of it. So the other point has to be over here somewhere. Great. Now, there are many ways to do this. One is to use a graph, which I want to show you. And two is some algebra. Because sometimes The graph only works well if the points are really pretty, like if the points are not wild decimals, yeah? But lucky for us, this is not a question with wild decimals, so we're able to show you both the graph and the algebra. Now, one way I love to do this, I start at the middle. Actually, does anyone have any ideas before I go ahead and give it away? Does anyone have any? Yeah, what do you think? So we're just going to draw that triangle, that rise and run, or that right triangle thing here. So we go down 1, 2, and then, so that's 2, and then over 1, 2, 3, 4. Okay. Yeah. So imagine we continue that pattern the other way. 2, 4. And we are hoping that this will be, well, actually we do know, that this is going to be point F, which is now -7, +6. That is for sure the answer, undoubtedly. That's how clever we are. Is there a way that I can maybe move this over just a little bit? Awesome. Okay. So if we're talking about this line segment, I'm going to draw it with a ruler. Ish. There you go. F is certainly the other endpoint, and we know that because the rise and the run. Yeah. Now, sometimes if the points are not so nice, what we can do is use this midpoint formula and leverage it to solve for the other endpoint. So we do know the midpoint formula, the midpoint of, in this case, it's EF equals x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now, similar to what we did in the past, in the past we had x1, y1, x2, y2, that was great, and we always solved for this midpoint. But in this case, we don't have both x1, y1, and x2, y2. We only have one of those coordinates. So let's just say we have, let's go ahead and say we have x and y. Do we have the first one or the second one? What would you put, x1 or x2? Doesn't matter. 1. Now this midpoint is actually the midpoint. Yeah, that is our answer. That's our answer. So when we plug this into the formula, yeah, this is the equal sign. The midpoint we know is -3, 4. That's the answer we're looking for here. And then x1, y1. Let me put x1, y1. Let me just. x1 is 1, y1 is 2. Now, at this point, we don't really know this. We don't really know this just yet. So we can say plus x2, not x squared, plus y2. Because we don't actually know what they are. So far, so good. We've subbed in everything that we know. Now, what we do know about this is that the result of this x, 1 plus something divided by 2, must give us an answer of -3. Yeah? Because the midpoint is the answer, and it's the average of the x's is how we get that -3. So let's put a little subheader here. Solve for x. We can say -3 equals 1 plus something divided by 2. Then we can go ahead and just solve this thing. just like we did in grade 9. I mean, I know it says x2 this time, but just imagine it just said x. So how do we get rid of this fraction? That's the first thing we do when we solve equations involving fractions. How do we get rid of divide by 2? Multiply by 2. So I'm going to multiply this whole side by 2, and then this whole side by 2. The 2's cancel, and we get something like negative 6 equals 1 plus x2. Well, we're isolating for x2. We're going to take this positive 1, bring it over here. It becomes minus 1. And we get something like negative 7 equals x2. And check this out. Hey, we got it. Likewise, this 2 plus y2, 2 plus something divided by 2 has to equal 4. Yeah? So 4 is going to be 2 plus something divided by 2. And the same idea, we're going to solve this thing as if, same way we solved the first one really, get rid of the denominator by multiplying each side by 2. On the right side, we just have 2 plus y2. On the left side, we now have 8. Bring this 2 over, it becomes minus 2. Eight minus 2 is just 6. And these together, the x2 and y2, are the way we get that other endpoint. Yeah? Lucky for us, we have some nice numbers here. We didn't have to go ahead and do all that, but there might come a time where this will come in handy, maybe in the homework, something like that. Questions about anything? Feel pretty good about it? I think what I'm going to do is, well, it's going to be kind of tough actually. Usually what I do is I put a unit 2 formula like on all the formulas we're going to learn. Because there's going to be some formulas you know, some formulas are going to be brand new like this midpoint one. So maybe take a piece of paper, set it aside in your binder and say these are the unit 2 formulas. The first one we should have on there is the midpoint formula. Because tomorrow there's another one coming. Wednesday there might be another one. So you know, and all these formulas would not be something that you'd be expected to memorize. That's not what we're doing here. You would for sure have them in front of you on any test or anything like that, but it's good to just really be familiar with them. Okay? So folks, in a textbook, page 78, 1 to 6 is really good. I think that first one and second one, it's just like, where's the midpoint on the graph? You could almost just drop your pen on it. Very similar to our first example. Number 9 is really good. In number 11, there's a star beside. And the reason why there's a star beside it is because it's a tough one. It's a really tough one.